Hello students. So in this video we are going to study about maximum power transfer theorem, and what is the statement of this is maximum power is transferred from the network to the load when the load resistance is equals to Thevenin equivalent resistance of the network. That is RTH equals to RL. When we say that RTH equals to RL, the maximum power will be transferred from network to the load. So this is a Thevenin's equivalent. We can say this is Thevenin's equivalent from this side and this is load resistance. So when RTH equals to RL, maximum power will be transferred. So we can say I here is VTH upon RTH plus RL. So what is the power? Power is I square RL. So I square will be VTH square upon RTH plus RL whole square into RL. For maximum power, RTH equals to RL. So this becomes 2RL. So when you put the value here to RL, that becomes maximum power becomes VTH square upon 4RL. So power max is given by VTH square upon 4RL. And again I'll repeat here, whenever we want to find the maximum power, we have to see that RTH should be equals to RL. So we have to find the Thevenin's equivalence of the network when we want to find the maximum power. Now let us see this question. I will solve this question. We need to understand this maximum power transfer. Find the value of maximum power transfer for the circuit given and also find the maximum power. This is the circuit here for which we have to find the maximum RL for the maximum power transfer. So this is the circuit. Just let us complete this first. So this is RL. This is 1 ohm. This is 1 ampere. And this is a dependent source of 2 Vx. This is 1 ohm and a voltage of Vx is here. And this is 2 volt. Now this has a dependent source 2 Vx which depends on Vx. This is voltage Vx. And this is a independent source 1 ampere. And this is RL. So we have to find the value of RL for maximum power transfer. For maximum power transfer, we know that RL should be equals to RTH. Right? So we will find the Thevenin's equivalent of this circuit first, and it has a dependent source. So we have to find Thevenin's equivalent with the VTH and ISC, because we cannot find RTH directly for this circuit because it has a dependent source. So what is the first step to find the Thevenin's equivalent? First we will find the Thevenin's equivalent of this circuit. In the last two videos we have got this Thevenin's equivalent, that is RTH and VTH. So first step is finding VTH. Now for first step finding VTH, we have to open the RL terminal. So when we open the RL terminal, it looks like this, right? And this is not a resistor, this is a voltage here of 2 volts. This is 1 ohm, this is 1 ampere, this is 1 ohm plus and minus and plus Vx, and this is 2 Vx. Now we have to find VTH, that is this voltage, plus minus VTH. Right? So we have to find this voltage. For that, first we have to apply the KVL here. What is the KVL here will be? Like we have to apply KVL in the outer loop for this, because we have two variables here, to VTH and VH. So we will first find, now this current here is 0. Right? Current here is 0. So we'll write down the KVL in the outer loop. Now first let us find the value of Vx first here. Now the current is I1 and the current here is 0. So you can see I1 is nothing but here minus 1 ampere. I1 is nothing but minus 1 ampere because I1 is coming down and 1 ampere is going up. I1 is 1 ampere. And from this we can say, when you apply KVL only in this branch, that is voltage into current, current into resistance will be your voltage. So we can write here Vx equals to minus I1. What is Vx here? Vx will be equals to 1 volt. So when Vx is 1 volt, now we can apply the KVL in the outer loop. KVL in the outer loop. When you apply the KVL in the outer loop, it becomes 2Vx plus Vx plus 2 minus Vth. You can see outer loop, we are going clockwise, plus 2Vx plus Vx plus 2 minus Vth. Right, plus Vx plus 2 minus Vth. Now, it will be 3Vx plus 2 equals to Vth. What is the value of Vx? Vx is 1 volt. So, we will write here 3 plus 2 equals to Vth. What is the value of Vth we got? Is 5 volts. So, Vth value is 5 volts. For this circuit, we got the first step. Let us find ISC, second step. And when you find ISC, you have to short circuit the terminal. So, this is 2Vx. Again, we will draw the circuit, but this time we will short the circuit because we want to find ISC. And as we know, we cannot find directly RTH. So, we need to find ISC here, that is short circuit current. This is 2Vx, this is minus plus Vx, and this is 2 volts and this is short. This is ISC. This is 1 ampere and this is your 1 ohm. Right? So, you can see here that we can apply, when this is 2 volts. There is only one current ISC here and this is 1 ampere. So, we will find ISC. Now, this is I1 and this is ISC. So, what is now you can find here, what is the value of I1? You can find the value of I1. This is, I can say this is I1. Apply KVL here and find the value of I1 because this is I1 is in this loop and ISC is in this loop. Okay, now apply the KVL here. Minus I1, this is I am applying KVL here in the outer loop, minus I1 plus 2Vx minus I1 plus 2Vx, or we'll write down in terms of Vx only, plus 2Vx plus Vx plus 2Vx plus Vx plus 2 equals to 0. KVL in the outer loop, this is the easier way because we are writing in outer loop. 2Vx plus Vx plus 2 equals to 0. So, 3Vx plus 2 equals to 0 or Vx is equals to minus 2 by 3. Now, when Vx is minus 2 by 3, when you apply Ohm's law here, what is Ohm's law here? We say that Vx equals to minus 1 into I1. Because when you write in terms of voltage, it is plus Vx, and you write in terms of I into R, it is minus I1. So, from here I can say I1 is 2 by 3. I1 is 2 by 3. Now, I1 is coming from here and this is 1 ampere is coming from here and this is ISC. You can see here that ISC equals to I1 plus 1. ISC is I1 plus 1. This is nothing but KCL. The outgoing current is the incoming current. Right? So, we can write here ISC equals to 2 by 3 plus 1 because I1 is 2 by 3. So, ISC is 2 by 3 plus 1. So, ISC is 5 by 3. So, we got RTH. Now, this is your ISC. ISC is 5 by 3. So, now third step is getting RTH. RTH is VTH upon ISC. What is the value of VTH we got? VTH we got as 5 volts and ISC we got as 5 by 3. So, this becomes as 3. RTH becomes 3 ohms. RTH is VTH upon ISC. ISC is 5 by 3 and VTH is 5 ohms. This you can see here, ISC is 5 by 3 and VTH is, what we got here is RTH is 3 ohms. Yeah. Now, next is we have to find the value of RL for maximum transfer theorem. So, for maximum power transfer theorem, it says that RL has to be equals to RTH, right? That is equals to 3 ohm. So, this is one value, first question asked. The second one is also find the maximum power. And what is the maximum power we have studied here? In the formula, it says that P max equals to V square upon 4 RL. V square upon 4 RL. So V square is VTH square. VTH square is 5 square upon 4 into 3. That is 25 upon 12. That is 2.08 watts. So we have two answers. The first answer is RL equals to 3 ohm for the maximum power, and maximum power equals to 2.08 watts. So thank you. Any comments? Please post.